Welcome to enthalpy. So enthalpy, symbolized with capital H, is defined this way. So H is equal to E plus PB. E, remember, is the internal energy of the system. P is the pressure of the system, and V is the volume of our system. So because internal energy, pressure, and volume are all state functions, this means that enthalpy is also a state function, which means that a change in enthalpy only depends on the starting and ending points, the starting and ending enthalpies, not on the path taken between our two endpoints. Right? So remember, heat and work are path functions, but pressure, volume, internal energy, and now enthalpy are state functions. They only depend on the starting and ending values. So what exactly is enthalpy? Let's consider a process carried out at constant pressure and where the only work allowed is pressure-volume work. This means that the change in energy is delta E is equal to QP minus P delta B, where QP is the heat at constant pressure. So this little subscript P means that we're constraining the heat there to be the heat transfer at constant pressure. We're not allowing the pressure to change, right? Which is also what we're doing here. We're not allowing the pressure to change there either. That's just one pressure value. So the heat is thus QP is equal to delta E plus P delta V. And now we can relate the changes in enthalpy to changes in the internal energy and the change in this quantity pressure times volume. So delta H is equal to delta E plus the change in, so delta, pressure volume, the change in that whole quantity of P times V. So the right side of that equation is equal to the right side of the QP equation. So that means that delta H is equal to QP. So the enthalpy is equal to the heat transfer, so the change in enthalpy is equal to heat transferred at constant pressure. So this equation is only true, it's only valid, if the process is carried out at a constant pressure and the only work allowed is from a volume change. So we're not allowing, say, electrical work to be done. So this means that the change in enthalpy is equal to heat absorbed by the system. Remember, Q is defined from the system's perspective. So this is the heat absorbed by the system at constant pressure. That's equal to our change in enthalpy. So for a chemical reaction, the enthalpy change is given by, so delta H is equal to the enthalpy of our products minus the enthalpy of our reactants. So if our products have a higher enthalpy than our reactants, then this is a positive value. If they have a negative, if they have a lower enthalpy than our reactants, then it's a negative value. So the change in enthalpy will be positive if our products have a greater enthalpy than the reactants. And in this case, the enthalpy change is attained by the absorption of heat, and the reaction is endothermic. On the other hand, the change in enthalpy will be negative if the products have a smaller enthalpy than the reactants, and in this case, the enthalpy change is attained by the release of heat from the system, and our reaction is exothermic. So that was enthalpy.